So, guys, in this video, let's take a look on the project's scheduling. So, how we schedule a project. So, the project schedule is projected a timetable of construction operations that will serve as the principal guidelines for execution. And 8 steps is offered as procedural guide. So, you can follow these 8 steps. How you can come up with the schedule for your project. So number one, you estimate the time required, and number two, you compute the time period required for overall project completion. So the total duration you need to have in order to finish the project. And then the third one is to establish time intervals. The time intervals within each activity must start and finish to satisfy the completion date requirement. So you must set the based on the duration, and then based on the contract award date, so you can come up with your start and finish date for each activity. And then after you come up with the start date and finish date, you identify which activities whose expedient execution is crucial, or we call it a critical task, critical path. And then once you identify those activities, you shorten the project duration by reducing the flow. You shorten the project duration at the least possible cost. At the least possible cost if the project completion date will not meet the contract or other requirements. And then the next step, once you remove all the float possible, and then you adjust the start and finish times of selected activities to minimize resource conflict. You want to minimize the resource conflict and smooth out demands for manpower and equipment using surplus. And then make a working project schedule that shows anticipated calendar date and start and finish of each activity. So you come up with the project schedule, the overall project schedule. And then lastly, you record the assumptions made and the plan's vital boundary condition. What are the assumptions being made? For example, you assume that there's no rain and fire activity can start as soon as site clearance finish. There's no cable found within the project area. So that sort of assumption should be recorded and it should be noted, so that during the operation, during the actual execution of the project, should the assumption being realized or not being realized, so at least you know what are the what are the tasks affected if your assumption was wrong. So what are the contingency that you can do in order to still meet the project deadline. And as laid out in the first one, first we need to estimate the activity, the durations for each activity. So here are the six rules for you to estimate. How can you estimate each activities? So rules number one, so you need to evaluate the duration for each activities one at a time independently for each other. So for a given activity, assume that materials, labor, equipment, and other needs will be available when required. Assume that there is no restraint on these three items: material, labor, equipment, and also if there are other needs for the activity. So assume that there is no restraint on that part. So what is the duration for the activity? If there is a fundamental reason to believe that this will not be true, then use of preceding restraint may be in order. So if you cannot, then if there is restraint on that part, so it will affect your duration, your estimation of duration for each activities. The second one, for each activities, assume a normal level of manpower and or equipment. So what normals mean in this context is difficult to define. It's hard to define. So for most activities require only a single crew of workers or standard spread of equipment. Based on experience, conventional crew sizes and equipment spreads have emerged as being efficient and economical. So in short, the normal level is about optimum amount of labor and equipment as expedient completion and minimum cost are concerned. So you need to consider your end date for your project and your cost that that is being used for during tendering station. So you want to use minimum cost and expedient time of completion. So that is normal. So for example, if normally only two machine of piling rigs can use for this project. So the duration should consider only two for piling rig. However, conflicting demands among concurrent activities for workers or equipment will be temporarily ignored. At this stage, conflicts are only matters of conjecture, and they will be investigated later during a stage of scheduling. So you can, leave out all these restraint first. So just assume your actual normal duration, normal manpower that is being used for you to estimate the duration for your activity. So the third one, assume a normal work day. So if time units of working days are being used, assume a normal work day. Do not consider overtime. Do not consider multiple shifts unless it's typical part of standard work day. Unless it is being stressed and you uh, in the project specification, or uh, you are costing for this. You really tender out the rate for overtime and multiple shift. Otherwise, you should only assume that it's a normal work day, no overtime or multiple shifts. So number four, you need to concentrate on estimating the duration of individual activities. Concentrate on estimating the duration of individual activity and ignore all other time consideration. Just a single activity. Just consider one single activity. So in particular, the completion date of the project must be put entirely out of mind. Otherwise, there is apt to be an effort made consciously or unconsciously to fit the activities within the total time available. So disregard the when you need to finish, what is the total duration of the project. Firstly, you need to consider how many days required for that particular project, for that particular activity only. Later on, then you adjust how many days, how can you adjust to reduce the duration of the activity. Usually this is by start work concurrently. You can add more manpower, so the duration will be reduced. Just a reminder again, this is an estimation. The rules on how you can estimate the duration of the project. Of course, the best estimation, the best estimator is the one that is experienced. Okay, but this helps you in estimating. This helps you in giving the best estimation for the duration of each activity. It can help you out. The fifth one is use consistent time units throughout. So don't change from days to hours, or month to days. So usually we use days. Usually we use days. And the sixth one is assume normal weather condition. So you need to assume there is no bizarre weather conditions like monsoon day. You can estimate, but You can expect that on Malaysia, especially during the monsoon season, or in Borneo during also near the monsoon season, right after October. But at first activity, firstly during the estimation, during the development of the draft schedule, uh, they need to be you don't need to consider that. Just consider that particular activity, so you can give the best estimation later on when you see the activities, for example, earthwork activities during the monsoon season in in December or January. So at that time you can change your schedule. Either you expedite the work, or you uh, delay the work, so that if you avoid such a weather, or you increase the duration of the work, because to compensate for the bad weather conditions. We've discussed this before. So this is your typical precedence diagram for each activities, sample activities. So you have identification number here. This number, usually you have like 1, so you add 0. If it is that activity is number 2, so you add 0 at the back, so it will be 20. And this example is actually 28. Activities 28. Then you add 0, it becomes 280. So that is your unique number identification at the middle top, and the middle bottom you have the duration. So this is your estimation, basically your estimation for this example, backfill abutment. So you estimate 3 days for you to complete. So you can sign these two numbers first during your estimation. And then in this precedence network diagram for sample activity, you also have uh, early start, early start. This is day 34. This is early finish, so 3:34 start on 34th, day 34th. So took 3 days to complete backfill abutment, so your early finish would be on the day 37. Day 37. Day 37. So at the bottom is the other way around. So you have early, so this is late start. So you late start, example, you have determined to be 40. So 40 times duration of 3 days. So you get your late finish. This is late finish. Your late finish will be on the day 43. Day 43. So see, this is the basic typical your typical networks diagram for sample activity, indicated sample activity. So in the middle you have this, in the middle you have activity, name your activity name. So this is another example. As you can see here, we have another example here. You have start, one finish, one activity at start, one activity at finish. So we have this example here, 3 is 4 activities. So you have, so this is your early start, early start, early start day 0. So this is your early finish, day 10. So how we come up with 10 is because you estimate the duration of this activity is 10 days. So this is not 10 days, this is your unique number, unique identification. So this is your late finish. We will go through how you can calculate these numbers. But having go through our discussion today, So you should be able to estimate the duration for each activities. This each activities duration. This is your estimation based on the normal number of workers and equipment and number of workload. For example, you can drive 5 of files per rig per day. Let's say you have uh, uh, you have 15 number of files in apartment 1, so your 15 number divided by 5 per day per machine, you get 3 days. This is one example of estimation. Okay, that's all for this video. We will continue on the next slide. Thank you.